In this video, we will continue our series showing how Syndeia uses digital pipelines to automate important tasks in creating, maintaining, and querying digital threads. By directly substituting autonomous digital labor for human labor, this approach clearly shows the ROI for organizations adopting digital engineering. In the previous video, we showed how a Syndeia pipeline examined a set of requirements and generated a report in Confluence listing which had test cases assigned through the digital thread and what the results of the testing were. Run periodically, this gave requirements engineers, test engineers, and project managers up-to-date information on a critical aspect of systems engineering, but it did not create new connections. In this video, we will take it a step further. A digital pipeline will look for matches between a set of requirements in one repository and the parts in a PLM bill of materials. Where there is a match, Syndeia will create a relation in the project digital thread. Subsequent runs will look for new requirements and update the list of relations. We use Jama and Windchill in this particular demo, but Syndeia has equivalent integrations to several other requirements and PLM repositories. One challenge is how Syndeia knows to add a link to the thread. In this example, it simply looks for matches between an attribute in the requirement and another attribute, the name in this case, of the PLM part. However, the pipeline could use more sophisticated semantic matching strategies, perhaps augmented by artificial intelligence, to create the digital thread links, probably with a human in the loop to confirm its determinations. One additional feature of this demo is the final step, where the URL of the PLM part is written back to another attribute of the requirement. This confirms to the requirements engineers, without calling up the Syndeia interface, that a link had been created, and even allows them to navigate to that part if they are authorized for the PLM repository. Gregory Seeds, a senior software engineer at Intercax, will demonstrate the pipeline in action.
What we're interested in doing is we're taking a set of requirements in JAMA, these spacecraft system requirements, and we're going to connect them to associated parts in Windchill. For the purposes of this demo pipeline, we've set a attribute in Jira that gives the name, just the name, no other identifying information, of the part in Windchill that is related to this requirement. We see for each of these there is this related artifact with the name of an artifact. Also of interest to the pipeline is this currently empty attribute related artifact URL, which will help us show that the pipeline has actually worked. The way the pipeline works is relatively straightforward. It signs into Syndeia to receive a token. It gets the artifacts from that JAMA repository that I showed you. It gets the artifacts from a given folder in Windchill and checks which JAMA artifacts already have relations into Windchill in order to avoid overwriting existing relations. It then follows a simple process to match those artifacts using that custom attribute as I've shown, and it creates relationships within the digital thread. Finally, at the end, it goes and sets a JAMA attribute, giving the URL link to the Windchill attribute, so that people using JAMA can see what has been linked in the digital thread. Within the Syndeia pipeline view, we can click Run, and we can watch an animation as this goes. So I envision this particular pipeline would probably be set up to run every day or multiple times a day to keep the total number of artifacts that it has to find the matches for relatively small. While that's running, we can also look at the table view, and we can see roughly how long it's taken in the past. Looks like it hangs out around 36 seconds. It's now setting JAMA attributes so that the backlink is visible. While that runs, we can look at the Syndeia digital thread, and here are our new relations. If we look at the graph view for the JAMA requirements, we can expand that outward and see not only the intramodel relations, but we're also able to see these new intermodel relations from Windchill. And finally, we can view that that link has been updated backward onto the JAMA artifact by checking over here. The nice thing about this particular pipeline is that it's idempotent. If I were to run it again, it would not create anything because it would find that all of the relations that it would want to create have already been created, because it includes a step that queries the digital thread and uses that information when it chooses to make the matches to the artifacts that it finds.
This same approach can be adapted to any combination of tools that Syndeia integrates to: requirements to software, test to project management, PLM to simulation, all building the digital thread in the background and generating, as we showed last time, regularly updated reports of the project status. To learn more, contact us at Intercax.